Now let's dive right in. This will be a good session on remote desktop gateway. This is actually part of, for those who've been following our webinar series, part of a series of Microsoft-oriented technology discussions that show reference implementations on how to deploy very specific Microsoft technologies. Remote desktop gateway is an important one as a bridge to managing and accessing any of the infrastructure you might run on AWS. And I'll talk more about how you can actually do that and then how you can secure your remote administration access to your Microsoft environments. This reference deployment guide actually includes, obviously, as Colin mentioned, the architectural considerations, things that you need to think about before your deployment, as well as best practices around security, a CloudFormation template, which we'll look at in more detail further in the presentation, which will actually automate the deployment and configuration of this entire environment. So really the whole point here is to show you how it's done step by step, and then also provide you the automation to make it happen within your own account. So you can test out this reference implementation for yourself very quickly in your own AWS account. So before we get started, this is an advanced topic. If you're not familiar with some of the core AWS services, or if you're new to AWS, then definitely want to spend some time looking at the Getting Started section of the AWS documentation. You'll find that the key services we reference here that are critical are Amazon EC2, and beyond just EC2, things like security groups, network ACLs, as well as Amazon VPC, which is a virtual private cloud service that allows you to define your software networks. Or your infrastructure networks. CloudFormation is also used as part of this reference implementation, which is a language that describes the AWS infrastructure you want to deploy the creation or create the deployment of, as well as even the automation of the bootstrapping the instances themselves. And we'll spend some time later in the presentation talking about that template and how it works. Those are the AWS technologies you should be familiar with. If you're not yet, feel free to open up a browser and go to those pages and follow along. Also important is the Windows Server Foundation and knowledge. So understanding Windows Server 2012 or 2008 R2, and also the remote Windows administration using RDP, or Remote Desktop Protocol. This is the technology that is used for accessing or jumping into a particular Windows Server instance, and then from there administering the server remotely. So that is a key factor in this, and it's really what this whole talk is about. Before we go too far into the implementation itself, or the reference guide, it's important to note how licensing works on the Microsoft platform with AWS. Actually, Amazon and Microsoft have a partnership for deploying and making Microsoft software available through the License Mobility through Software Assurance program. So you're able to, in many cases, move licenses from your existing production infrastructure onto the AWS platform, as long as you have software assurance, and it falls those tools fall under the software assurance umbrella for migration or portability. The Windows Server, which is really the core focus for this particular implementation guide, is actually provided for you. So the Microsoft Windows Server license is included in the cost for running Windows Server on top of AWS. So those are built in, so you don't have to think about migrating licenses in that particular scenario. If you were to install other Microsoft Server SKUs or tools such as SQL Server, Link, SharePoint, those would be items that you could bring your own license. And in fact, we even have a third model for certain items, such as SQL Server Standard, where we have an hourly rate that we will charge you to cover the SQL Server Standard license in a Windows AMI. So there's a few different licensing models that exist. For this particular reference implementation, we're focused on core Windows Server components and Windows Server tools, which, as I mentioned, are included as part of the pricing around EC2 instances running Windows. So that takes care of that. There's a couple links on the page that are worth looking at, though, if you're thinking about migrating other components, server components to the platform, and how license mobility works. So what we're going to cover today is what are some core considerations for deploying a remote desktop gateway, how you then set it up, how you configure your clients, which are then the machines that will be accessing the remote desktop gateway, and then further jumping into the infrastructure inside the environment. And then we'll cover the automated deployment, which is really about the CloudFormation template and how that works. There's two scenarios that are included in there. I'll talk briefly about the difference between the two of them, but we'll look at the common template, which creates the entire infrastructure for you. So considerations when deploying remote desktop gateway. Um, the thing to remember is this is intended to be a, if you will, a bastion host, a jump server, an entry point into the administration of your entire Microsoft stack inside of AWS. So this is obviously a very important entry point to secure. So there's definitely some key principles on how you do that. This is if somebody were to get onto this particular box from here, they could jump into the rest of your environment. And obviously, you can secure box by box, and integrating with things like Active Directory and Active Directory accounts will help, protect you against various scenarios of people having the one password everyone uses. You can have individual passwords for users, but it's important to realize that this is an important entry point to protect. And what we like to espouse when talking about any security concept is really this idea of principle of least privilege. So whenever you're building out a piece of infrastructure, you want to limit the capabilities that users of that component have all the way down to the least amount of capability, so that they couldn't actually, you wouldn't want to make them like, say, an admin on the entire environment, admin in the world, and jumping into that particular box. You want to give them only the capabilities from a Windows Server roles and responsibilities perspective that minimizes them, as well as you want to reduce the attack surface area of that environment. So that means when people go to, if they want to get on that particular machine, they should be very limited in their network access and port access to the machine. They should be limited where they can come from. So it's really all about reducing the attack surface and exposing a minimal set of capabilities as well as ports, and even source IPs from which you can actually access that infrastructure. So the security groups, and we'll talk about how this is done, but obviously concepts like, which ports are open for security groups, then filtering the source IPs of the traffic coming into those machines, as well as then obviously locking down the functions and capability within the Windows operating system once somebody's on that gateway. Those are definitely key things to think about. Another aspect of what to consider when deploying the gateway is really how you set up the virtual private cloud. So VPC is, in another parlance, sort of a software-defined network that allows you to carve out, if you will, a VLAN of the infrastructure that you would like to make available for provisioning of IP addresses, subnets, and traffic flow. So you can carve out public subnets which have direct access to the internet, private subnets which need to go through a NAT to get to the internet or have no internet access at all, creating subnets, and you can isolate the traffic between them. This allows you, and the whole purpose of VPC is really to allow you to define a virtual network topology that closely resembles what you might need for your specific environment. So, do you need subnet isolation between layers in your application? Do you need a DMZ, a public subnet area, versus a private subnet for your non-internet accessible components? And those are definitely core thoughts that you want to go through and how you design that network. And that's where the VPC service comes into play. You have complete control, obviously, over this environment. You can select your own IP ranges. You can create your own subnets. You can configure the route tables and network gateways. So you have complete control of what you do, but this is definitely something to plan out up front before you go to a production model. And the one key thing to think about here is, in this particular scenario, is network access control lists. So security groups are obviously, and we'll talk about those in a second, but security groups allow you to do stateful connection tracking and determine whether the particular packet being sent to an EC2 instance should be allowed based on rules. Network ACLs are one step outside of that and control the access between subnets. So these are stateless, so it's important to recognize these are, unlike security groups, they don't do connection tracking for you, so every packet is inspected and it's not correlated to an ongoing TCP connection. Therefore, you have to open ports for the inbound access. So say if somebody's calling into a web server, the port 80 inbound access, as well as the ephemeral outbound ports upon which that response can occur. So that is how these are defined. They're definitely at the subnet level. They sit outside, and they filter traffic between subnets. So if you wanted to have a tight filtering of traffic that can go from your remote desktop gateway into your private instances, like your Windows servers running SQL Server or Active Directory, a network ACL can sit between those layers, allowing you to tightly isolate the traffic between the public side of the DMZ and the private side, which is not direct internet accessible. And since this remote desktop gateway is the jump point into your environment from administration, considering how you might configure and set up those ACLs is definitely worth looking at. If you use security groups very, very tightly and control it that way, you may feel comfortable leaving network ACLs open because you already have the isolation at the security group level. But this gives you a further tool to further isolate traffic or block traffic across subnets, and it allows you also even to do separation of duties, where a network administrator might be able to change ACLs, but somebody else in the company may be able to modify security groups. Therefore, if somebody makes a mistake on one end, the other administrator has to make changes too, sort of a separation of duties. So security groups couldn't be changed to allow something that never made it through the network ACL anyway. So something to consider there. Obviously, it's an effective way to blacklist CIDRs or whitelist or blacklist CIDR blocks or individual IPs. And you can actually create ordered rules. So the rule numbers actually are executed in order until one rule is found that matches the traffic, and that rule is then applied. Security groups are at the next layer in. So network ACLs are between subnets. Security groups are on the instances. So this allows you to set policies to control which ports are open and provide isolation between application tiers. It acts, if you will, as a instance level firewall, but it's not in the operating system, but rather below it at the hypervisor layer. So what that means is traffic will never bubble up to your web server in the web server or the web tier security group unless it is following the pattern that is defined by the security group. So TCP port 3389 coming from the remote desktop gateway or gateway security group. Security groups can be filtered based on CIDR rules, but they can also be filtered based on other security groups. So if you look at the diagram over here, you'll see that there's the RD gateways in the gateway security group and the web servers in the web tier security group. The web tier security group could easily have a rule that says, I will allow traffic on TCP port 3389, which is the default RDP port, but only from machines in the gateway security group. So even if you had 20 or 30 RD gateways, by having that one rule, you've referenced all of them as a group by referencing their security group, and then allowed yourself traffic to flow from the RD gateway to the web server group as well. So security group rules can actually be broadly applied. And as you change the security group, you affect every running instance that has that particular security group. So single point of definition broadly affects traffic and actually doesn't need to be specific to IP. So let's go into the remote desktop gateway setup. So the initial remote administration architecture is to set up this multi-zone kind of model. If you see here, there's a public subnet, there's a private subnet, there's setting up the security groups for the gateway and the web tier, and then there's defining the elastic IP that gateway accepts traffic on, and then you pass along. So servers, the public subnet will need inbound security group rule for permitting TCP port from the administrator source IP or subnet. Windows sitting instances behind should be in their isolated in their own tier. So this allows you that ability to filter traffic and isolate. So those private subnet instances, such as the web server in this case, are not directly accessible to the internet. You may wonder how a web server could not be directly accessible. It should sit behind an RD gateway in this case, or like an elastic load balancer. So the entry point should be tightly controlled, and then traffic could flow into that private subnet. You can then use this remote desktop gateway box as a sort of a jump server, and then that's how you would then administer. So if you want to administer the web server, you would jump through the remote desktop gateway into the web server. So that's an important aspect. In this particular diagram, you'll see it has remote admin machine is coming on 3389. That's a default configuration, but you could change that very easily too, and we often will suggest to move that to 443. So it's an SSL, so it's an encrypted connection. And then you would set up SSL certificates on the server as well as possibly on the client, depending on the type of SSL cert. And you can define connection authorization policies about who can connect and what resources they can connect to behind the scenes. So you do have a lot of administration options here and the ways to lock that down. So gateway installation actually happens as part of the CloudFormation template, but it's fairly simple to install the gateway components. As you can see here, a simple PowerShell command of install Windows feature, RDS gateway, include management tools, will go ahead and install those components. Once it's there, all the prerequisite software will be installed as well, and that's part of what happens in the template, and we'll look at that in a minute. The next thing to think about is actually setting up SSL certificates. As I mentioned, moving to SSL allows you to encrypt the traffic using either public key cryptography or even or even self-sign. So you could actually use a root certificate authority, go to VeriSign or other certificate providers, and purchase a public certificate that then has a root CA that's outside of your environment, or you can create your own. By self-signing a certificate. That gets you up and running in 5 minutes, 5 to 10 minutes to quickly generate this certificate. However, that does come with a client configuration step where you then have to copy that certificate down to the client so it knows about it. So it has a way to look it up. The choice you make about whether you self-sign versus public is really about what are the downstream clients do you control? Can you push a certificate to them, which would allow you to do self-signed? Or is it, no, they are coming from a variety of devices that you can't perhaps manage or control, in which case, going with a public key or publicly signed cert would be a better choice. In addition to the SSL configuration, there's also connection and resource authorization policies. So connections, RD caps as they're called, I define who can connect to the gateway. So for example, in many cases, generally is the case in almost all Microsoft deployments on AWS, there is, in addition to this gateway, there is an Active Directory deployment, which allows you to reference a domain. And so you could say all domain users or all domain admins can connect. So you define that policy based on referencing the users and groups defined in the Active Directory that sort of sits behind and outside of this gateway. Additionally, you can obviously create individual accounts and do it that way as well without a domain controller. This really comes up to you depending on the size of the environment and the how much infrastructure you want to deploy. But many production workloads, Active Directory gets pulled in at some point, and when it does, you have the ability to reference it through caps. Resource authorization policies are then the next layer of saying, okay, based on those users coming on, and here's the resources behind the scenes they can connect to. This gateway obviously is a pretty powerful component. As you connect to it and you have access to it, it could allow you to jump to many other boxes inside the infrastructure. You could instead say, well, no, I'm going to limit the exposure and say I'm going to allow people to do remote desktop administration of the Microsoft SQL Server instances, but only for this particular group of domain users. Right, so you have the ability to find these caps and wraps that will be useful for filtering and controlling who can access what components. So as you can see here, as I mentioned earlier, we highly recommend and suggest the creation of SSL certs or installation of SSL certs as a manual step and then moving that to port 443, at which point you quickly modify the security group for the gateway security group, and you drop port 3389 and add port 443, such that only the secure SSL-based port is available for access. So you can ensure that traffic coming into that gateway is encrypted in flight, and that certificates are being used in that particular scenario. Increases the security of the connection, and also prevents the need to initiate an RDP session to the desktop of the RDP gateway. So you don't have to, at this point now you can jump through the box, and there's client setup steps as well that we'll talk through that show you how you can not even mention the gateway itself, but jump right past it straight into the web server. So let's go to that, client configuration. So obviously setting up your client configuration requires the installation of root certificates if that's necessary. If you went out and purchased a certificate from a root CA like VeriSign, then that would be a publicly accessible certificate chain. Your client could look it up and then be comfortable with it and verify it and not have to have a certificate installed. If you do self-signing, you do need to deploy that certificate to the client, and in that case, you need to install it. Obviously, you need to set up the name resolution for the remote desktop gateway fully qualified domain name, or FQDN. So the client that is going to connect has to know how to, via DNS, look up the gateway. So you would have DNS entries that you create into the elastic IP of the remote desktop gateway, and then that allows the client to resolve the name, and that then is configured as a proxy, if you will, in your remote desktop connection client. So so when you type in the name for the server you want to actually administer, say that web server might be 10.1.2.3, you could type in 10.1.2.3 directly into your remote desktop client, even though you're not even on that network. But you would set up the remote desktop gateway as your proxy or gateway for the connection. It would then be forced that connection through the gateway, which could resolve the 10.1.2.3 and send you to the web server inside. And that's the proper configuration of the remote desktop gateway step. That is number 3. So those are ones, and that actually is covered with some nice screenshots on how to do it exactly in the white paper. So if you want to see the steps on how to set that up and configure it, definitely reference the white paper. It has the screenshots and the dialog boxes you would use to set those up. The last piece is obviously the automated deployment of this entire thing. There's 2 scenarios that we think make sense to make available to you as sort of out of the box. One is obviously the creating of a gateway, but in a brand new VPC. So this is, creates the virtual private cloud. It defines the subnets. It creates the availability zones that you need. It actually launches the remote desktop gateway instances, configures the security groups and rules for traffic between the tiers. It sets up the AD sites and subnets. It does actually a lot of those steps. So it really does a lot more than just the couple of boxes you saw in the previous diagrams. And in fact, it really doesn't set up the web server, but rather the AD and the remote desktop gateway. So you have the ability to jump right in and start sort of playing with it. This is a great way to get started if you're not sure you want to try it out and you don't want to use your existing VPC. You want to try it out in a clean VPC to see what it looks like. The template defines a whole bunch of different customization options. I'll talk about that in just a second. The second one is if you want to do this as a standalone template that only does the gateway, so into an existing VPC, in which case you would have to then provide the information about what the VPC ID is, the subnets you want it launched into, security groups it'll create for you, but then you might have to then modify existing security groups to reference them for traffic flow between. So things like that are all kind of part of that template. So it allows you to launch configuration of a remote desktop gateway directly into an existing VPC. So with that, I'm going to jump into the template itself, give you a sense of what's going on here. So obviously, there's a lot of things to control here. Many of these have defaults, so you don't necessarily have to make choices. So, for example, the EC2 instance type for the gateway is an M3 extra large as the default, but you have other values you can choose there. You can give it, NetBIOS names. You can control those. You can use you can create username and password for the administrative account. Obviously, post-launch, you could change that, but this is just something to create for the initial launch and provisioning of the environment. Fully qualified domain name, for it, so it knows how to get, look itself up and be looked up. CIDR blocks for the public DMZ, the private DMZ, all that kind of fun stuff to control the subnet addressing. So you can see there's AZ1, AZ2. So this is a multi-AZ HA scenario where there's a remote desktop gateway, one in each subnet in each AZ. So you have the ability to control and deploy infrastructure in multi-AZ scenarios. So you can jump into an alternate AZ if there were, AZ issues or network connectivity challenges. From there, I'll jump into, actually the mappings are less exciting. I'll jump into some of the resources that are being created. You can see this creates a VPC. It creates a subnet down here, and it goes through that process of creating all these various subnets. There's 4 subnets created by this internet gateway. Does a gateway attachment, does the route table configurations. So these are all actually baked in here. The route itself for the various subnets are all part of this. So you can see that this is obviously a fairly long template, but what it's doing is really building up and creating the entire VPC for you. Let's jump down to perhaps the more interesting section, which is where some of the instances are created. So for example, here's a remote desktop gateway. It's an EC2 instance, and it depends on NAT1 being done because it uses NAT1 to reach out to the EC2 and the AWS service APIs. So you need that NAT1 in place. It actually does a CloudFormation init using CloudFormation, which is also installed and made available as part of the Windows stack as well. And it does, config sets. It does config, so it does setup, rename, install RDS, finalize. And then it does, various steps inside of that. So for example, in setup, it's just setting up and configuring the CloudFormation stack, pulling in pulling in parameters that are needed to run the CloudFormation templates and know what region and stack the environment is in. It will do it will actually pull in, let's see here, it will run this particular script, which is a PowerShell script that it pulls down from the local C drive. It's been deployed there. That will actually do some configuration of the remote desktop gateway itself. It makes sure services are running, so CFN HUP. It renames the machine, and then it will install a remote desktop gateway. And you can see here, there's the exact example we showed from the presentation. Install Windows feature RDS gateway, rsat-RDS gateway. So that's some features are then added automatically with PowerShell, creates admin users, sets the admin group, configures the gateway itself, and then goes ahead and does some finalization steps. So as you can see, not only is this creating the resources, it's then also doing a dynamic configuration of various components. Many of the steps that are defined, however, in this thing, such as installing SSL certs, creating SSL certs, things like that, are steps that need to become after the fact to get that fully up and running, to switch over to the more secure SSL 443 port 443 configuration. So definitely extra steps you want to take there, but this will automate building up the environment to allow you to dive in and then further lock it down appropriately for your uses.